So we're officially recording class. This is August 30th, 2023. And so we're going to start talking some kind of GIS applications of statistics, on descriptive statistics. Hello? Can you hear me? Can you hear me? Yes? Okay, good. And just make sure, those of you join us online, make sure you mute yourself there. Yeah, everyone looks like they were muted. Okay. Gotta put you all there in the corner there. And so we're talking about the idea of statistics. And we're talking about global statistics versus local statistics. So global statistics are going to be examples that describe the entire data set, where that local statistics describe one particular county, or later we're going to be talking about polygons. And so we talked about, and hopefully everyone can see it here, we had a z-score, which was z is equal to x minus x bar divided by the standard deviation. Now, some big questions are, z, what does z measure? Tell me in your words, what does z measure? What does it measure in your words?
Standard deviation.
Yeah, what's it measure? Standard deviation is what? Now, it could just be colloquial terms.
Is it like how far something is off?
Off of what?
From a point, I guess?
What point? The mean. How far something is away from the mean. A couple things to think about. What are the units for a z-score? Actual units. No units, exactly. They cancel themselves out when I subtract dollars minus dollars, and dollars divided by dollars equals goodbye. And so when we think about this, what are adequate units for z-scores? Like, what's a good, I showed some chart and standard deviations and all that other stuff. What a good unit? Like, is 82 a good z-score? Because when we talk about like median household income, we're talking about, I've got some data here sitting here, like $44,000, $34,000, $61,000. Is 61,000 going to be a good value for a z-score? It's definitely going to be something that we pop into here, but when we go through and divide by all this stuff here, it's not going to be an acceptable z-score. And typically they range from about -3 up to like +3, 3.5. A lot of times you hear the term z-scores when you look at like testing, there's 2 standard deviations. Sometimes you hear the word percentile because, well, they put you into percentiles as opposed to that. But one of the things, especially with this hurricane going on now, especially with GIS in the last 20 years, has been measures of social vulnerability. Has anyone heard that term, social vulnerability? So, how vulnerable are, populations, especially, or resiliency to things like natural hazards. So, who are going to be the people that are least resilient? Okay? Whether it's low income, older, high minority, or however you kind of measure this resiliency or lack of resiliency, how do we measure those? And when we look at these, when we look at dollars and years in age and all these other things together, we can't just add those units up. If we have something like 2x plus 3y, what's 2x plus 3y equal to? 2x plus 3y. We can't combine those units together. And so they're typically going to be standardized using the z-score. Now, we can also do this using our Excel here, because those of you who I met with, we went through and hand calculated these, meaning, all right, we went to POP 2013 and we got the average was 98,000 and the standard deviation was 147,000, and we went and looked it up for Durham and just said 248,540 minus the mean divided by the standard deviation and calculated. Then we went to a different county and did the same exact equation where that the mean and the standard deviation was the same thing. We calculated it again, and again. Straightforward, pretty, I don't want to say easy, but once you get the hang of it, this is just an equation. We've got, one equation, we got, one unknown, these things can be calculated. Now we can also do the same thing here, where we can calculate the z-score. Okay, we can just calculate the z-score. So we're just going to do a simple z-score. And what we're looking at here is per capita income, median household income, forget about population. But what we're going to do is we're going to find the z-score for each of these counties based on the median household income. So the first thing we need to do in Excel is what's the mean? What's the mean of these things? And I can calculate a formula right here. Remember we did this last week where I said it equals, you can type in the word average. What? Now, remember, what is this thing here? Remember in math class right here, we have this little left parentheses. What's the left parentheses mean? Remember, like f at x, what are these things called? F at x equals 2x plus 3. You plug in the little 3. These things are called parameters, input parameters, all the things that go into a function. And so when I typed in average, I said, all right, what do we want? All right, the average of number 1, number 2, number 3. And what I'm going to do is I'm going to just go up to the very top number, my little parentheses, and it says C2 colon C101. What's C2 colon C101 mean? Exactly, the whole row from cell C2, okay, C is being referenced using the column, 2 is referenced using the row number, all the way down to 101. Hit enter. So it's 40,808. And then I could do another thing where it's the standard deviation. And I'll just take first one right here. It's the same exact thing here. So there I go. So I've got my mean and my standard deviation. Now, silly question. What if a county happened to have the same exact value as the mean? What would the z-score be? What's that? So if I had a county that happened to be 40,848, what's the z-score? What is the mean standard deviation? We're getting making you think real quick today, real early. Okay, well, here we are. X is the value of the county. So if I have a county equal to the mean, what's one number 48 minus 48 equal to? 0. What's 0 divided by this equal to? 0. So you got 0. If the average is more than this number, it's going to be positive. If it's less than this number, it's going to be negative. So we have a good idea as to what a good answer looks like because we can go through and just pop these things out in Excel. Pop these things out in Excel and run these. So I can calculate a z-score now equals, put a little parentheses, the value. Okay, so Alamance minus this number right here divided by this number right here, all right? I'm gonna hit enter. Units are a little weird, so watch this. I'm gonna do format cells. It's just a number, boom. All right. So it's 0.43. Okay, meaning Alamance County is 0.43 standard deviations above that. Now watch what I can do here. I could just go and drag the rest of these, right? Uh-oh. What's happening? What's going on? Uh-oh. What's it doing? Anyone see what I'm doing? Basically, I'm dragging down so it's calculating these, but I want these columns to stay the same, these columns to change, these columns to stay the same. I'm not dragging down here as well, right? Does anyone know the little trick Make sure these numbers right here stay the same. Getting real deep.
I was trying to remember last class, but.
Okay, good. We got a little dollar sign meaning. So we got a little dollar sign here. A little dollar sign there. A little dollar sign there. And a little dollar. And watch what I do here. What's the dollar sign? Can you explain it, Benjamin? Because I don't think I explained it well enough. What's the dollar sign mean?
Well, it means that it's not gonna change based on, like, whenever you do like copy paste, right?
It's not going to change. Basically, you notice as I'm dragging down, I'm doing 63,000 minus this number, 30,000 minus this number, 32,000 minus this number, because in Excel, when we drag, we want to move everything as it goes with it. So with the dollar sign, it just says, hey, these two are going to be the same. Everything else is going to be moving down. And then for some reason or another, we got these really weird numbers here where they're in red or whatever. Yuck, I'll just put it in general because I don't know what that means. So there we go. So now we've got 1.98. Where do you think 1.98 is? This is Chatham County. We got Tamar, she's from Chatham County, right? There she is. About 1.98. Per county is 1.98 standard deviations above mean. And if you really wanted to get kind of tricky and figure it out, we would multiply 1.98 times the standard deviation and then add it to 40,848. That's how you get it. So we got a good idea. Now, if we were to sort these standard deviations, I see a 2.99, I see a negative 1.44, and we can look at this, the distributions of these and kind of figure these out, sort these, do it, I see a couple high ones here, and we can make a nice histogram of these. What I'm going to do here is, tomorrow I'm actually going to work from home, and I'm going to put together a tutorial on how you can go back and forth between Excel and ArcGIS Pro, because I can make the histograms and all this other stuff here, but I like making the histograms in ArcGIS Pro because I have to create something here called a pivot table. Has anyone heard that term before? Pivot table means it creates little bins. Remember what bins are? What's a bin? The range of numbers which we calculate frequency. And you notice when you made some of those bins for like Pop 2013, they looked kind of weird or odd because we weren't working with normalized data. So today we're going to focus explicitly on working with and the idea of normalizing data. And I've got some really neat applications that we've talked about because even when some data are normalized as rates, they're still not normalized as rates, or they're still not standardized. So we'll talk about these. And so be on the lookout tomorrow. I'm going to kind of work on those all day tomorrow. So to go back and forth between these, because I kind of look at this and like, you know what? It'd be really cool for me to just bring this into ArcGIS Pro and work with, bring this into ArcGIS Pro and start making histograms and charts and all that other good stuff as well. Or I could kind of copy it in Excel, copy it in ArcGIS Pro, pop it into Excel and do the statistics, the two-tailed t-tests, and all the other things that we're going to do later. Because we can calculate mean, median, range, standard deviation real easily, real quickly in ArcGIS Pro, right? Right mouse click, create chart, statistics, we're there. And it's already doing what it wants to do. I can right mouse click and click statistics, and I've got a chart much easier than the time it would take me to make a chart here in Excel. So, we've got some really good trade-offs. And so some of the things that I really implore people to do is, start to figure out what is going to be your kind of go-to tool. What is going to be the thing that you want to work at? What is going to be the thing that you're going to be good at? I kind of talk about the idea or think about the idea of systems approach. What's a system here? Today on campus, I spoke to a lady over at Deputy Director of NASA. So of all the whole country and our 4th district congressperson. Does anyone know who that is? Who did you vote for in the last election for House of Representatives? Whoever had the little R, the little D next to their name? You know what everyone does? So anyone know what it is? The Valerie Fouché. Fouché. She went to UNC. I'm pretty sure she's Democrat. And then we also met with NASA administrator, meaning there's not one person who can figure out how to get to the moon, right? So we gotta break these problems into some smaller sub-problems. And so, if we're gonna do some of the projects we're talking about here, where we're mapping African-American female breast cancer death rates over a period of 20 years, like you gotta figure out, where am I gonna get the data from? What am I gonna do to it? How am I gonna display it? And then we can start to it's probably about 4 or 5 different separate problems. And within those, you're gonna have some sub problems there. So we talk about this systems approach to these, and what we've been doing with these exercises is the same thing. Where that, you notice exercise number 1 is just exercise number 2, where I just did exercise number 1. And then what do you think exercise number 3 is gonna be? It's just what we did last week, just building upon that and looking at the standardization dates. So I don't want to go too far afield with some of these things, but today I'm going to talk about those. The other thing I did want to show was there's some really neat jobs out there. I was looking at a couple of things here, like the GIS Jobs clearinghouse right here. I love looking at these because this is how I got my job 20 something years ago. This thing has been around forever. And so I thought this was pretty neat right here. I'm always employing people. This is the Central Lincoln People's Utility District in Newport, Oregon. So this is a really pretty part of the country in Southwest Oregon along the Pacific coast. I just thought this was interesting because I've been seeing more and more GIS applications as it applies to utilities. Because utilities are basically a network, kind of like roads. Everything is connected to each other, And these days with cell towers, something physically, power, whatever physically has to get to the cell tower before it can transmit or do whatever. But I thought this was neat here because we had health GIS, which was big the last few years. We've got utilities, and then business analytics, or BIM, business intelligence mapping, is just another thing that's really taking off. So if we go to gjc.org, I also have a link to that in some of my external links here. These are just some of the jobs out there. And as you go and start looking at some of these things here, here's another one, Providence, Rhode Island. Anyone know where, has anyone been to Rhode Island? What's the superlative for Rhode Island? What is it? What's so famous about Rhode Island? Smallest state. When I was born there, my grandmother, she lived there. She's, I guess, technically still there, but she lived there. So really nice little state there. It's right near Quahog. So you guys know where Quahog is? Has anyone here heard of Quahog? You guys watch Family Guy? Exactly. That's the show in Family Guy. So they talk about Portuguese people and Family Guy because it's a big Portuguese population and everything. Yes, good. We've got someone. Now, A for today. But GIS system specialist with Providence Water, because water isn't just going to hop from one place to the other. It's going to be connected via network, and it's important that these networks are going to be interconnected. So territory analytics, I think I showed this one last week. This is pretty neat for Sunbelt rentals. Where are we going to build the next Sunbelt rentals? How are we going to get things from one place to the other? So, obviously places like Amazon or USPS or UPS has their foot in the market with GIS-based solutions for logistics and analytics. We're starting to see other places that do this. Previously, we saw a job for one of the auto parts shops. Where are they going to build the next auto parts shop? The green one. What's that one? O'Reilly. Yes, I was going to say it's Irish. I thought it was Irish, but O'Reilly Auto Parts. And so they were hiring someone to do that as well. So today I don't want to keep us here all 3 hours. So I was going to talk about the idea of normalizing data, giving everyone a chance to catch up a little bit Meaning, I'm not going to ding people too much for late exercises because the exercise I'm giving today isn't due for 2 weeks because it's going to be covering this weekend, covering next week. So hopefully everyone had a chance to go through and do the GIS basics. So you got an idea of kind of the clicking and all those other things. And I think they elucidate some of the things that I don't do because I like, clicking the black plus sign and doing all this other stuff and adding data. And I'm still kind of getting used to adding services. Meaning you log in using your NCC username and password. I don't have to go look for counties sitting on my flash drive or computer. I can just go to my organization and then start to add things. I can start to add things. So if you go in your organization, you can see all the data that I've added up there as part of the exercises for this class that I export out or any of the other classes I have. So if you want to use base maps and counties and everything else, I've got those up there. And so we're going to talk about the idea of the need for normalizing data. Now, I already talked about the idea of I have something cool that I found on the internet. And when we do our in-class exercise, we're going to focus on the North Carolina Vital Statistics database. I've got a couple things in the back here that were pulled from that. But we have literally a big list of every single person who died in the state over the last 20 years. It's like close to 2 million people. I guess like about 100,000 people die every year in North Carolina, and there's information collected about those. So we can look at things related to coronary disease, cancer, and when you die, you have like a little code attached to you of what you died of. And then if there's like exacerbating or extenuating factors where you had asthma and this and that, it'll include those, but things like happen at once. Like an automobile accident, it's probably one thing you died of or whatever. And so we've got all this.
I just have a question about the tax ID.
Yep.
Does that include like mental illness or is it just like physical illness?
I don't know. We could check those.
I'll
Yeah, you can.
look more into it.
No, because it's ICD code, so maybe the manifestation of mental illness might be like suicide. It's probably going to be listed as a suicide or whatever. It'd be listed as a suicide or unintentional death or whatever, whatever those things are. But there's something called an ICD code. It's called International Classification of Disease. So you look up the code and you can see, type it in, and it's got what the code is. Anything that begins with the letter C is always going to be cancer. So we can just find everything that begins with the letter C and go from there. So I'll show that after the break just to show you where I got the database from, because this is part of that systems approach where that, there's not just going to be some magical database sitting out there of every single person in the state of North Carolina who died. Someone at some point in time had to go and put this all together. And there's a lot of, we looked at some of those at the beginning in week number 1, right? Where what they died of, their address, male, female, and we kind of cleared out some of that information. Now it's collected at the zip code information. So we can bring this into a GIS and we can run things like summaries. It's basically like running a pivot table which counts the number of times something occurs. And then we have something called joins. So it's a popular function to give tabular data spatiality, meaning I could stick it in a big Excel spreadsheet, but I'd rather turning it into a map. And so we've got joins here. A join is typically used to append. What's the word append mean? You kind of hear of it, right? Like an appendage. What's an appendage? Something that's like connected to you, right? So we got this append, append means just to stick on. So we're sticking one table right next to the other table. Well, that's kind of convenient. So what can we do? Right, and we can do this based on relationships, spatial relationships, which we call a spatial join, right? We all know the spatial join. We use the spatial join to do what? Count the number of cancer deaths within each county. We've already gone through and done that, and we're actually going to build upon that this week, and then we'll kind of look at another exercise as well. So typically, I have something here called a standalone table right here. And so this is a standalone table. This is a standalone table. This is an attribute table, meaning that I can see that this is CSV, so I can bring these things into ArcGIS. So that's what I mean by, I've got something in Excel, I can just bring it right into ArcGIS and start doing all the queries that we're used to doing. Now, each of these 51 states is going to be connected to a point, line, or polygon. Now you notice there's 51 here, probably because it includes Washington, D.C. But I have a field here called state. I have a field here called state. Wouldn't it be pretty cool if I were just to add this table to the end of this table? So now I can map all the stuff here so that these are connected to points, lines, and polygons. That'd be pretty neat. This is what we covered in our kind of intro class. And to me, to be honest with you, some of the join stuff was real ugly for me when I was getting into this a long time ago. So our whole goal is to kind of make a map out of this. I'd rather make a map out of this instead of just looking at a table. And so I can run a tabular join. Now, we already ran spatial joins. So you right mouse click, you go to joins. Now, what we're going to do today is we're going to do something called the summary. And then we're going to do a join, and then we're going to make some nice pretty maps and talk about the idea of normalizing these. And then next week, we're going to talk about change detection analysis. Oh, what's change detection analysis really mean? The big fancy word for saying what?
See things.
See how things change. What's the graduation rates from 2015 to 2020? What's the death rates from 2015 to 2000? That's it. Nothing fancy, nothing special. We call it CDA, change detection analysis. And our GIS tools, our GIS tools, if you have the columns for like the number of deaths, it has really neat ways that you can make maps that show like things changing and all that. I'm not really good at that. I'm not that much of like a movie maker or visualization person. So maybe that's going to be the thing that you're going to be really good at, especially if you're artistic, coming to us from art or having an art background. We'll want to look at really neat things above and beyond the maps that I make. And so we've got this spatial join right here. And I said, hey, I've got something here called the key. This thing's here called the key. Now this thing is called state name. This thing's called state. It doesn't matter because everything here is the same. Now I can make a nice pretty map so that now I can make a map of helmet laws by state. And I go out to like Ohio. We go to that Twins Fest out in Ohio, and I was in Indiana with my wife. My wife's out there right now, and you see people like driving around without helmets. Well, why? Because they don't have to. There's no helmet laws. Now, just because there isn't a law, does that mean you have to drive without a helmet? No. But there are no helmet laws or whatever. So we can see all the different types of helmet laws that we have here. So that, helmet laws for Illinois and Iowa are not required at all. Okay. For this one, Indiana here, required by law under 18 and required for instructional permit holders. So anyone over the age of 18 in Indiana does not necessarily have to wear a helmet while riding a motorcycle. If you don't want to. And so, but a few minutes ago, this was just sitting as a standalone table, sitting in Excel that I downloaded, that I brought into Excel. Because we'll get to a point in time where we can click that black plus sign, add data. Now we can add data sitting anywhere. We can add pictures. In our 4010 class, we added like pictures, historical pictures taken of historical maps from Durham or Asheville or whatever, and we gave them GIS coordinates. We also have reasons why joins may fail, meaning if I spell things wrong. Remember, computers are stupid. So if all these state names were capitalized and all these state names weren't capitalized, they're not going to match up. So if I had this in Excel and I wanted to make everything capitalized right here, I'm looking at this right here. So I'm working with a GIS data layer and it's got all of the state names capitalized and I want it to match up. Do I have to start doing this? Do I have to hit like caps lock and go PLAMAC? ALEXANDUR. Do I have to do that for all 100 counties? What are you going to say? What would you do, Jayla?
I'm pretty sure it's a function.
Yep, there's function in there, definitely. And so a lot of times people don't realize we've got a lot of math functions. I can add this column plus this column, divide, subtract, all these other things. But there's a number of string functions out there. And one of these string functions it's called upper. I believe it's called, right? Upper. Yep. And what's it say here? Upper converts a text string to all uppercase. That's pretty cool. Okay. What's the text that I want to change? I just want to change this thing to uppercase. And there it is. So now I can make everything uppercase. So if I'm working with a GIS data layer and an attribute table, that's all capitalized. There it is. I've got it right there. And a lot of times if you download data from the North Carolina Department of Public Safety, where it has like prison entries, it provides the data as all uppercase. So you got to kind of do something with that, make something capitalized or whatever. So we can do this in Excel. The function might be slightly different in Python, which is the scripting language for ArcGIS Pro. It might be something like ucase or something. I wish they were all the same. But we've got this here. What case? Does anyone, this isn't uppercase or lowercase. What case is this where the first letter is capitalized? What case is that? You know what that's called? That's called proper case. Is that what you're thinking? Okay, you're right. That's all right. No, we're in a safe place here. So proper. And so back to here. Right back to our proper case right here. Or I can make it all lowercase or whatever. So we can go. So catch. All right. So we can go back and forth between our different cases. We can do searches and all those other things. You know, you do searches all the time in Google or whatever. We just don't really think of it. You know, we can put little things in quotes and it has to have this name or whatever. And so we can do the same exact thing here, especially when we're parsing out data or whatever. So we've got these here because my main focus is it's not much in the book here. And I really want to get hands-on today is that just making people understand and appreciate the idea of normalization and standardization. So we've got these spatial joins. We already did this, right? You know, which state has the most number of tornadoes? We kind of hit the ground running with this week number 1, where I gave you every cancer death, you counted them by counties, and then we kind of went from there. Because I've got 1,500 of these right here. We ran a spatial join. We ran this. We ran target features. While we were there, we were running statistics. So what I did was I mapped this join count right here. And this is kind of where we're going to pick up today, where that, all right, this join count right here this is the number of tornadoes. It's good. You know, I don't mind this, but, you know, and I got the number of deaths right here. So I got maps, I got deaths. But what's the challenge with this? You know, someone's going to look at this and say, Pennsylvania and New York have so many tornadoes because what? Why do they have so many tornadoes, do you think? What would your argument be? Wind tone? They're big. They're bigger. So there's more of a chance of a tornado happening here or here than here or here because they're just so big. And so essentially, when we're mapping physical phenomena, we're mapping like socioeconomic phenomena or crime phenomena. You're mapping places, especially with raw data, where there's population or area or some other type of standardization. And so I can map the deaths. I can map the average number of injuries. Now this gets a little bit different, right? You start to see it go from over here to over here. So now for tornadoes in Connecticut, Massachusetts, and Rhode Island right here, they've got average number of injuries per tornado. That kind of makes sense a little bit more. Now with normalizing data, is mapping the total number of tornadoes the best idea? And I think we answered the question, no, it probably isn't, because it's just going to be skewed to bigger states as well as other kind of physical factors, meaning, you know, in the Piedmont and the coastal plains are a lot flatter, so more of a chance of them happening there. But even Wake County is going to have more tornadoes than Durham County because it's 4 times the size. So what we're going to do today is we're going to calculate a new column that represents the number of tornadoes per 100 square miles. Now, why do I want to do it per square mile? That's pretty easy, right? Calculate these things. So I want to calculate these per 100 square miles or per 1,000 square miles. And so for a place like Wake County, it might have 35 tornadoes. Anyone know the size of Wake County area? A pretty big county. I'm going to say it's about 850 square miles. What's 800? What's 35 divided by 850? Alexa, what's 8? Oh, Alexa's not here. This calculator's going. 35 divided by 850 equals 0.0411. Okay. 0.0411. What's that mean? What's that mean? Okay, for every square mile, what's a square mile? 1 mile by 1 mile area. It could be a 2 mile by half mile area. It could be a 3 mile by third mile, just 1 square mile. We got an idea of what area looks like. Okay, for every square mile, there's 0.0411 tornadoes. What does 0.0411 tornadoes look like? Now, it's hard to look at that. What if I moved it over 3 places? When you move things over 3 places, you move the decimal point over 3 places. What are you multiplying by? What are you multiplying by when you move the decimal place? 1,000, exactly. So now I've got 41.1 tornadoes for every 1,000 square miles. What's 1,000 square miles look like? It's about the size of Rhode Island, but we have an idea of what that looks like. And so when we talk about normalization, a lot of times we think about that with like homicides. Okay, I live over in Greensboro. We've had about 35 homicides this year. Population is about 600,000. So if we were to look at the number of homicides per capita, per person, we're looking at what kind of number? A really, really small number. Like 35 divided by 600,000 equals, oh, yuck, look at that. 0.00005833. What does 0.005833 people look like? Oh, no. I know what 5.8 people for every 100,000 people looks like. I know what 0.58 people looks like for every 10,000 people. What's 10,000 people look like? Can you tell me 10,000 people? What would 10,000 people represent? College campus, that's exactly what I was thinking. This college campus with all faculty, staff, and students is about 10,000 people. So for every this group right here, we have about a little 0.5, almost 1 homicide for all of this group. So we can compare this rate to another rate, to another rate, to another rate, to another rate. So a lot of times when we look at these, we try to avoid per capita or per square mile because we get these really, really small numbers that I don't know what 0.00005833 homicides look like. I know what 5.8 homicides for every 100,000 people looks like. And so those are just some things to look at because a lot of times you might see a map that looks like this. This is heroin-related deaths in North Carolina. This is Guilford County, and when we look at heroin-related deaths, basically, what are we really mapping here? We're really mapping heroin-related deaths. We're mapping population. We're mapping population. Now, if you want to show where all the heroin-related deaths are, have at you, but essentially, we've got all the high population counties right now. So we can map deaths per 100,000 people, and so we can go and calculate brand new columns. Can you calculate brand new columns in Excel? We just did, right? Didn't we just make a new column? Hey, let's call it ZScore. Let's call it upper. Let's call it lower. Let's anything. So we can make new columns. We can do the same thing in ArcGIS Pro. And so when we normalize, mapping the total number of tornadoes by state, no, we want to calculate a new column. Then why not per square mile? Because you're going to see someone like this at a conference and say, well, I don't really care about this map. I'm just mapping population. And so if you ever go to a conference and we have workshops here and we have lots of like symposiums, We've got someone who's been down to the Coast Guard before, and you're like, what are the 3 words that people never want to hear when you're giving a talk about stuff? I don't know. You don't never want to say, I don't know. So, hey, why did you map this like this? Oh, I don't know. And so make multiple maps. So always be careful for the person sitting in the back of the room saying, uh-oh, they better ask a question where I don't answer, I don't know. That's really important, especially if they're giving you money like that, people down at Coast Guard or however that worked out. I don't know is a good question. Now you can follow it with like, I don't know, let me get back to you. They probably like that a little bit better. So we can calculate brand new columns right through. Yeah, and that's what we're going to do today. We're going to run little summaries, little joins. We're going to kind of work with our tables right here and do that. So now we can look at things like tornado density. These are the number of tornadoes per 100 square miles. You notice what happened to New York? It went down. Pennsylvania went down. Now we've got Massachusetts, Connecticut. What's this great state?
No way, this.
It's New Jersey. Oh,
It's not.
no one knows New Jersey. This is like part of the test. That when I grew up there, I couldn't see another house that was nice. My parents had a nice house. I just lived there under their mercy. So, all kidding aside here, but you can see where these things moved from Pennsylvania, New York to over here. This is a better kind of indicator. A couple things I'm going to kind of mention here. We'll take a break and then we'll kind of work on the exercise. Like I said before, I wanted to kind of work a little bit more hands-on today, but we talk about metrics that should be normalized versus metrics that don't need to be normalized. So things like number of cancer deaths per 100,000 population. And we're going to kind of talk a little bit more about that. Number of tornadoes per county, number of tornadoes per 1,000 square miles by county, because all the counties are different sizes, right? Now, in a few weeks, we're going to do some GIS magic where we create units that are the same exact size. These things are called quadrants. Why would we create units that are the same exact size? What value does that bring me? Bring you? If all the units are the same size, what's the good thing about that? If this square has 50 and that square has 60, which one has more? That one. That has a higher density because they're all the same size. Now, what are the bad things about it? Well, I've got a square 10 miles by 10 miles. Do I know how many people live in that thing? No. I know how many people live in a county, block, a tract, which don't take on nice, pretty square units. And so there's some trade-offs to those, and we'll talk about those. And so things like the number of deer vehicle sightings per census tract. We had a student who came to us from NC State. He did ecology. So he was an ecology person. And he wanted to look at deer vehicle collisions and all the factors related to those. Now, most deer vehicle collisions occur near roads, but they didn't occur in the inner city, right? Why? Because, well, deer are going to be scared of there. They didn't occur out in totally rural areas because, well, there's no people there. So they occurred where there's kind of like what they call the UI interface, urban wildlife interface, where there's people and deer. So has anyone ever hit a deer? It's not fun. Yeah, it's not fun. I got squished a couple. It's not fun. So look at the factors attached to those. I take it, did you hit it on I wasn't a rural road, it's kind of suburban road, I guess?
Actually, it was in the city.
Oh, in the city. Oh, so it was like one of those crazy deer. Okay.
The deer be eaten.
Yeah. Oh, yeah. Yeah, these deer.
Like near the highway.
Yeah, they just like hang out there. And then you got those crazy ones that's like make a dash for it and whatever. So I've hit it 3 of them. But things like, we're talking about the idea of standardization. Total number of highway distance by state. Like how many interstate miles are there within a state? Well, obviously California, Texas are going to have the most, but per unit area. Average distance to the nearest healthy food store by census tract. The average distance to the nearest healthy food by rural census tract. And a lot of times when we look at non-normalized and standardized version, if we're talking about urban versus rural, there's two different dynamics there. And this kind of gets into my food access research, where that if it's rural, it's going to be far away from everything. So we might want to tease out your urban, rural, suburban census tracts. Now, how do we define urban? How do we define rural? Whole nother thing. Have I talked about that stuff before we did? Yeah. There's 9 different definitions. As long as you're consistent with those. Total income, average per capita income. And those were some of the data that we're calculating with the Z-scores previously. Population change by county, percent population change. New minus old divided by old is percent change. Meaning, if this county gained 15,000 new residents last year, is that a lot or a little? A lot. Some counties. What if it had like 1 million people in it? That's not that much. It's 1.5%. But a county that had only had 15,000, that's a 100% increase. And so if you have to say the word "it depends," then it needs to be normalized. And then things like total amount of rent, median monthly rent. So whenever we use the word medians or averages, that means that it's been standardized. So we normalize the following data. So these are like EOG scores. So this is percent. So basically, we have schools that provide report cards that give us the percentage of people who don't pass EOGs or non-passing rates, so we can look at these. These are high school graduation rates. Because if I just looked at the total number of graduates, well, the total number of graduates here in Wake County is going to be really high, but when we look at the percentage of total graduates, it's going to be a little different. Here's a map here. Prison re-entry locations. I used to work for a place called the Center for Community Safety. What does this look like to you? This is where all the people, return from prison and they go. Does this make any sense? Really? Now I can look at prison re-entry rates, density by population. So these things here are census blocks and census tracts and census block groups, which are subdivisions of counties. And so I can run a nice little spatial join, count the number of people within this thing, and then divide by population, multiply the whole thing times 1,000, and get that rate there. And so we can provide, adequate services for prison reentrants living in these particular locations. Child maltreatment. So the abuse and neglect reports for every 1,000 people. These are just some examples right here. And so we're kind of evolving from maps like these where I kind of say no duh sort of thing here. This makes sense right here to making bigger maps here. Dispensing per 100 people. Now we're looking at rates here that look a little bit different here. Now we're looking at Wake County. That's got a really small dot, where Wake County here had a really big dot, because what are they doing? Now they're looking at deaths per 100,000 people. Now you can start to see out in the western part of the county, southeastern part of the state right here, or western part of the state here. Now that's where opioids or whatever we're looking at here, fentanyl or heroin or whatever, is going to be a major challenge. And the other thing we've got here is we've got COVID-19 Dashboard. Now the COVID-19 collecting dashboard kind of ended back in May. We're going to still be working with these data because they're largely going to be spatial in nature. But we've got a zip code, cases per 100,000 residents, cases per 10,000 residents, 100,000 residents, and deaths. So the one challenge we have when we migrate these things, and I'll kind of jump ahead of things, meaning when you download these things and bring these into ArcGIS Pro, is that this number right here, it's a zip code. Is 27006 any better than 27007? No. But when you bring these into Excel, or bring these into ArcGIS Pro is like, hey, cool, I've got numbers. This is 20,006, 27,007. So it treats these things like numbers And so we've got a number, we've got a number, we've got a number, we've got a number, we've got a number where that your zip code is really text, right? Where I grew up, my zip code was 07865. And so if I were to look at my zip code here in Excel and then bring it in ArcGIS Pro, it's going to be 8765 because like I don't need that zero. This thing's a number. So you really need to tread carefully with making sure you bring in the right stuff in Excel and ArcGIS Pro, treat everything nicely and neatly. I like working with files instead of Excel called CSV files. Has anyone heard that term before? It's a file format. It stands for comma separated values. It basically means that if you were to look at the raw file, it would just be separated by commas. And so Excel says, wherever I see a comma, I'm just going to make it a new column right here. And it's a little bit more of a base form, a more basic form. It's been around for a long time. And so they're called CSV files, but you can go up to the top and click File, Save As, and you got a big list of things. Now, Microsoft wants you to save it as a .xls or whatever that, whatever the format is these days, .xlsx. Does that sound right? Something like that. It saves it like that, but there's lots of other formats that ArcGIS Pro likes a little bit better. And we're not going to do too much with that today because I went through the trouble of bringing everything in for you. And then we have things called age grading. So now what I did, and we were doing our work on African-American female breast cancer death rates, and we actually started to look at some really neat charts and histograms of African-American female breast cancer versus everyone else. And we made some nice histograms. We saw for African-American females, it was kind of the histogram was real high in the late 50s, while everyone else was the late 50s, meaning that breast cancer death rates were probably still high for everyone, but the age at which people died were a lot less. Do you think that's coincidence? And later in this class, we'll talk about statistical tests to look at that. Now, it was probably due to access to resources, morality, all the other things that, think about all the trouble you have to go through to go to the actual, doctor. I'm sitting here right now and I've got a bill from my wife from Cone Health. So really, I had to take a kid to an emergency room or whatever. And, luckily we kind of got the resources to figure it out. But, you get a $1,200 medical bill, what are you going to say? Sorry, not paying it. I'm lucky enough where, all right, I'm not happy about it, but I'll pay it and then go argue with someone and get some money back. So that's another thing. But so what we've got here is mortality rates here. Basically, when we look at cancer mortality rates, what ages of people die at higher rates than other people? Old people. So when you're mapping this, you're basically mapping where the old people are. And you can see, over here in Orange and Wake County, where there's a younger population, these mortality rates are really, really low. So even when we map rates, we're still kind of doing the whole no-duh thing that we need to take it a step further. Now, this is the paper that we did with the PhD student, Alana, where that we went and made these. And now we weighted these by age. Have you ever created a weighted average before? I hope so. This is what we were doing last week, right? Whenever you calculate your GPA, what do? You weight it by age. Or no, not weight it. You weight it not by age, but you weight it by what? Credit hours. So not all A's are the same. The A with 4 credits is going to be more than the A with 2 credits, which is going to supersede the D with 1 credit. So we did some neat work right here where we used Boucher, who worked for the North Carolina Department of Health Statistics. And so we age graded things here. This paper is sitting in there. We're not going to talk too much about this. But with this map turned into this map here. Now look at Wake County here. A little different, especially southeast Wake County. Okay, you go to southeast Wake County, now look at the cancer mortality rates. Here, right? And we still see a little bit of this checkerboard pattern right here because of the way that we weighted it. We kind of threw in this formula because we weighted it by the percentage of people within each age cohort. You heard the word cohort before? What's it mean? Exactly, group by year. So we looked at, let's look at the percentage of people aged 0 to 20, 20 to 40, 40 to 60, 60 to 80, because this census tract, this zip code right here might have a really high death rate, but if all the people were over the age of 80, then it's going to weight it a lot less. You know, you think of it as like your one credit day, it's going to be weighted a lot less than your age group, like here, like here in Southeast Raleigh, would probably have a lot more death for age 20 to 40, 40 to 60. So this, and now we can map this. Now, who decided on the colors and the scheme for this right here? We went through and made this map. Who decided how this map's going to appear with these colors and these divisions? Who are you pointing at? Me, I did. You know, I was the one who decided that. So I could change the way this appears, because when we start to do like cluster maps and all these other things, is that it's going to be based on the data, not the way that I want you to look at the data. And we still have things like outliers right here. So if you have a really small zip code that has 100 people and like 3 people happen to die of cancer, what do you think that's going to do with the rates? Boom, shoot it up real high. And so a lot of times when we look at things like infant mortality rates, and they break them down by race, you might see some Western counties here that have really high rates of African American infant mortality rates. Well, why? Why would the rates be so high in these Western counties in North Carolina for African Americans? What about, are there a lot of African American population in the western part of the state? No. So if you have 1 or 2 deaths, what's that going to do? It's going to pop it up really high, because there wasn't a lot of African Americans or over up here Native Americans or Hispanic or whoever, and so some of these race cohorts are really going to really high. Wow, 50 people for every 100 people died. You know, infants died, half of them. Well, if there's only 5 infants and 2.5 die over a period, or 10 and 5 die, you can't have 2.5 infants die, but you know what I mean. Well, we have that. And so what we're going to do when we get back, we're going to open up something called case study number 1. Like I was saying, we'll come back here at 6:10, and I'd like to get out of here by 7, just because I got some things I got to take care of at home. And like I said before, I want to give people a chance to play some catch up. And then as well, exercise number 3 isn't going to be due next week. So exercise number 3, we're going to have the first part we're kind of working on today. And then the second part we'll do next week with change detection analysis. So we can kind of start with the exercise, but I want to get us, let's take a break, because I'll stop talking and we'll meet back here.
Are you having a class next semester that's kind of like, yes, but like here to like criminal justice?
Yeah. How did you know that?
I feel like you said it, but I just wanted to make sure. Like, I've been trying to talk my sister into getting to GIS, just like one class. But she was like, I'm like, girl, it's everywhere. And if she, because we graduate, so that was her big thing. Like, it was like, not it's great.
Yeah.
You have to take an intro first.
No, it'd be. I think our plan, what we're hoping to do is have this class at 10 o'clock, and then 34-35 be offered at 9 o'clock. So you do intro, then you take this class, but it's going to be basically, and me and McGinn are teaching it, so it's going to be like application. It's going to do like geocode. It's all going to be specific, focused on crime. So it'll be like select by queries, cluster maps. So it'll be everything that we do in this class, 40-10, and this focused specifically for crime analysts. I'll be back here.
Dr. Maroney,
Yes.
Really quickly, could I ask, after class, could I ask you a question about the homework?
Yeah, of course.
Yeah,
Who's this?
it's
Oh,
just with the Z scores. I just was having trouble. Like, I figured out how to do it. I just could not find a field where I could get the numeric answer, if that makes sense.
okay, all right. Well, yeah. And what I had people, anyone that I met with, we kind of hand jammed those, and so we'll talk, we can talk about how to hand jam those and kind of go from there. So
Okay, awesome.
okay,
Thank you
I'll
so
see you in a little
much.
bit.
I just wanted to just learn about
Mm-hmm.
street. Yeah, it was like so many.
Those spirit.
Oh, yeah, not spirit.
We thought I like that.
I was with them.
Jordan is in there. Jordan Harrison. I think he's in there.
I was in this.
The whole class on this book thing.
I mean, just about, you know, with things like that.
It's the part under the question, right?
Yeah.
We'll start back up here in about a minute or so. Okay, we got Barbara there. We got Caitlin. How's it going, Caitlin, out in Asheville?
I'm good. How are you?
Good, good, good. My daughter's out at Western Carolina, so.
Oh, nice. I live like maybe 45 minutes from there.
Oh, okay. Yeah, I've been out a couple times there.
I love Silva. It's very small town, but I love it out there.
Yeah, oh yeah. We got Kai, we spoke before in person. We got Chantel, good. We got a nice group here. Good, good. Okay, so what we're gonna do today is we're gonna open up this case study number 1, and we're gonna open it up in ArcGIS. So once again, remember, this is a zip file. So we gotta extract it and then double click on the little icon and open it up so that we get something that looks like this here. And we're gonna get something that looks like this. So remember, and those of you following along, just so we kind of remember, this is called case study number 1. We could just download this thing. Where does it download? If I click download, where does it save it? What file? What folder? Downloads, yep, downloads. Now, when you look at it in downloads, if I were to kind of go look at it in downloads, because a lot of times, if I were to look at it in downloads, here's my downloads right here. If I were to look at it in downloads, this is called a zip file. You can see that it's compressed, so I can't open stuff up. Even when I click on it right there, it's got a little prompt up at the top that says extract all. So what do you think it wants you to do? Extract all. You know? And so pay attention to this, because your Windows Explorer is going to look a little different for a regular old file as opposed to this. And so I can extract all. Where do I want to save it? Save it where you can keep track of things. And this is one of the soft skills that we need, that we required out there, is kind of keeping track of stuff. You know, where are things saved? Project management. You know, I think back when I started here, you know, people would come in with their computers and like, you know, where is it? I can't find things, all that other stuff. And you know, I get real like, come on, we gotta have this stuff ready to go. But when you're set here now, do you see anything up here that says extract all? No, why not? Extract it. Okay, extract it. Okay. I know this is, you know, a little bit of a learning curve for you all, because a lot of times we got stuff here ready to go here, you know, and we can do the online version of the GIS software, but it's not as powerful as this. And when you look at any of these jobs, people are going to want you to be able to use this stuff in addition to the online stuff. And we are, you know, in our 4010, we do ArcGIS online, and we add maps and do all that other good stuff there. Now, what we're looking at here is we got zip codes, and we're kind of continuing on a little bit with looking at some of these death rates, but we're looking at an area here of southeastern North Carolina. These are zip codes right here. And so what we're looking at, zip codes right here. If I right mouse click, I can probably do a little bit of my GIS magic where I can kind of, can I label stuff right here? Can I label? Oh, I can click the little label button so I can see what counties I'm looking at. So is anyone from Bladen, any of these counties right here? That'd be funny if Tamar was from Moore County, wouldn't it? But she's from Chatham County, a little further up. But I don't think anyone's from any of these counties right here. But you can see the kind of the outline that we've got right here. And if I were to right mouse click and open up my zip codes, some of the things of note that we're kind of looking at here is that I've got a zip code, a population 2010, and a state, and I've got a postcode, post office name. Now, the one thing that you notice is that the zip code is left justified, the number is right justified, right? Do you notice those? Okay, and there's a reason for those, is because it's treating these zip codes as strings, treating the numbers as numbers. Okay, and in particular, these are what we call long integers. What's an integer? Numeric value, like what? 2, what about 87.3? Is that an integer? No. It's not, because it doesn't have a decimal. So an integer just doesn't have a decimal. Because something like Pop 2010 doesn't need a decimal. Your GPA needs a decimal. And so all the ones and zeros to store those decimals get really ugly that we don't really care about. So we have longs and shorts depending upon the nature of the data. If we really wanted to, we could click these 3 little buttons right here, and we can click on Fields View. Fields View, and you can see what we've got here. Whoa, look what I've got here. You go to Fields View, you can see zip, post office name, state, Pop 2010. Look at all the stuff that I didn't show you, right? So I showed you a whole bunch of stuff here in zip code that I really didn't bother. You know, like median age 5 to 9, zip 1, all this other junk here that I probably ran some spatial joins on or whatever here. But for the most part, I'm kind of just showing you the main stuff right here. Okay, so I'm showing you the main stuff. Now, what I have here under standalone tables is that I got a standalone table. So if I right mouse click, it doesn't say open attribute table. It just says open because it's not an attribute table. An attribute table is going to be connected to points, lines, and polygons. And so if I were to highlight in my table this, this Sanford one right here, if I were to highlight 27332 in my attribute table, something on the map is going to pop up. And I think we're at a point in time where that we can kind of go back and forth between the maps and the tables and the maps, and kind of be comfortable with those. Now, if I right mouse click on coronary heart disease death, this is what we call an attribute table. And so now, what are these looking at here? What are we looking at? And essentially what we're looking at is I took data from this database right here. This is the North Carolina Vital Statistics Database. The Vital Statistics Database. And so we can download every single person who died. And you can see, so that you can see a list of every single person who died. So I can click on the Vital Statistics Database. I can go down here, and I can literally download it. Okay, so this is the data. This is .date, this is .tab. What do you think a .tab file is? Table or tab. So like kind of like comma separated values we were talking about before, where it has little commas. Here it's just got a little tab. So you hit the little tab, if it goes over a tab, so everything's lined up nicely and neatly. So if I really wanted to, I can download this file right here. Did I click on it? Did I download it? I swear I know what I'm doing. I really do. Okay, tab. I can click on this file right here. And so I can download this as a tab limited file. Let's see what it looks like, just for the heck of it. I'll go to my downloads. And this is where data management comes in, because all those African-American female breast cancer deaths, do you think there's some magical database sitting out in cyberspace that has all those that I'm just ready to work with? No. How did I get those? I got the 2003, 2004, 2000. I put them all together. I made sure all the columns lined up. Then I started to get some big Excel spreadsheet that had 1 million records. Okay, and after about 1 million, Excel starts to say, we're not getting along here. Okay, and it has a limit of about 1 million. It's like 2 to the something power. So I do all this stuff on GIS Pro. But it takes a while to get to 2013, 14, 15. So this is what I talk about with kind of some, project management and all these things. Like think that you're going to map all the female African-American breast cancer deaths in a single night. Hey, I'm just going to spend the night downloading the data. Next night, I'm going to spend putting the database together. Next night, I'm going to spend is making sure these columns line up. Next night, I'm going to finally turn it into a map. And that's what we're going to do right now. And so when we look at these, and there's like a lot of context that I have here. But now when I look at this is deaths 21. So this is every single person who died in the state of North Carolina in 2021. Opening it up and really bad things are going to happen here. Why? Oh, look at all this. Yuck. Does anyone know what this is? Anyone care what this is? No. But guess what I'm going to do? I'm going to open it up in Excel, and maybe Excel will be a little bit smarter for me. So I'm going to go to Open, Browse. And these days, especially when you save stuff and open things up, it gets really ugly. That's okay. Because it always wants you to store things where? On your cloud. I think it's kind of some sort of government conspiracy, but that's another thing. Okay, so here, what am I looking for? Anything. Let me all files. Here's my deaths 2021. So this is every 74 meg. All right, next. I have headers. Tab. It's pretty smart. It's like, hey, I see tabs here. Cool.
Is that on Canvas?
I have a link to it, yes. Oh, the file which file that we're this?
The one you just downloaded?
No, because I literally just downloaded it. So now what we're looking at is a list of every single person who died. Death state, NC. What do you think D state NC means? That's where they died. D state, NC, PA, NJ, NC, MI. What do you think that means? Where are they? Now this is different than when we looked at the last data set, right? Because then they give you like 34, 35, 36, all this other stuff. So the bad thing about working with this data set is that the naming conventions are always changing. So you're working with 34, 35, 36 up until 2018. Now you're working with TX, MI. Who's going to change all those? You are. Are you going to go hand type those in? Probably not. You could probably do some nice little find and replace or something else to do that. But this is some of the challenges that we have here. Because I'm looking at this here where, all right, we got Merrill. Were they, I don't even know what these mean. These are new codes here, to be honest with you. So we all have a whole bunch of new codes here. We have a code for veteran status. Was the person who died a veteran? So we can kind of look up these here. And so we can see W19, ICD code for W19. This person who died on 1/3/2021 at the age of 103. What's that mean? ICD code W19. I don't know. I don't even know what that is. Unspecified fall. This person died of an unspecified fall, age 103. I see that happening. That's what happened to my daughter's great grandmother. But we have this here. So now when we look at this, we've got about 122,000 deaths right here in 2021. So I would imagine a lot of these, I'm sure there's a new ICD code for COVID or whatever here, but you can see some of these are going to be maybe singletons here, where they might be, car accident or something like that. So like I-250 might be something, entirely different, like I-250. No. Acute and subacute endocarditis. Oh. Arteriosclerotic cardiovascular disease. So they died of one thing there. Now, the thing about this is that, well, I would love to map these folks, but if I look all the way to the right, what do I have here? A zip code. Do I have the exact location where they died? No, I've got a zip code. The zip code, can we stick that onto a map? Of course we can. So these tab files, what I could probably do here is go File, Save As, Browse, and you know what? Instead of storing it as a .txt, I'm just going to store it as a .csv file, and I bet you I could probably bring this into my ArcGIS and start clearing things right here and right now. And I'll do a little demo just to prove that I'm right, or pretend that I'm right. And so I can add data. So I really wanted to, I could go to downloads, top. Here's my deaths.csv. This was sitting on the North Carolina Department of Vital Statistics a little bit ago. Now look what we have here. I've got all 100 and something thousand deaths here, sitting here, ready to be queried. Now, can I do select by location on these things here? No, but I can do select by, look, I could do select by attributes. I can export these things out to their own table. The one thing about this is that this is CSV, where these files are sitting inside of my database. And so when we actually look at the database right here, if we were to look at folders, this little thing right here, this is a database right here. This thing called case study, and it's got some tables, it's got counties, it's got zip codes. And so this thing is stored outside of the database. It doesn't mean that much versus store it inside of the database, but I could just export all this stuff to my database and work with it in there. There's not much of a difference. Me personally, I like exporting everything inside. One of the reasons is because it's all in the same place. You know, so when I click my black plus sign, I can just add everything right there. It's in the same place. And as long as I give it a good name, I'm happy with it. And so we've got some easy ways that we can go in and out of Excel with these standalone tables. But what I've got here with this coronary heart disease death is, this is a list of everyone who died of coronary heart disease deaths from 2011 to 2013. And so you notice some of these codes look a little bit different now. You know, with marital, now it's like W. And so this thing gets really ugly if we're doing some real longitudinal research. What's longitudinal mean? Anyone hear that term? Over a period of time. Because, all right, I've got the marital stuff, that's 1, 2, now it's got WMD, you know, widowed, married, divorced, or whatever here. I've got these different codes here. Hispanic might be something different. Birth state, all this other stuff, making these things line up. It'd probably be really neat way to, there's probably neat ways to translate between these, but that'll probably take a little bit more research here. So we've got 35,401 people that have died here. And if I go all the way to the right, I've got a zip code that is stored in here. And what I want to do is I want to count, then normalize by population this area right here. And then we'll talk about age grading and change detection, all that other stuff later. Or that, hey, let's look at the change from 2011 to 2012 to 2013. And that's what we're going to do next week. So my trick is here, I want to get a summary table that just has a list of all the zip codes and has the number of deaths, right? Zip codes, deaths. How can I do that? How can I do that? Now, those of you kind of new with GIS, this is kind of what we covered in chapter 7 in the book. I want to count the number of times zip codes appears. I want to say, hey, 27253 occurs 17 times among this big list of people who died of coronary heart disease. Anyone remember that function? Summarize, exactly. Now, how do I find the summary? Exactly. When in doubt, right mouse click. What do I have here? Sort ascending, sort descending. We're going to look at this in a little bit here called calculate field. So under zip code, have we done statistics already? What if we ran statistics on zip code? Is it going to give you anything useful? No, because it's nominal data. It's the name of something. But I have something here called summarize. Yeah, I've got something here called summarize. So I got an input table, I've got an output table. Yeah. And the thing about this is that now if I click on this, where am I storing it? Case study one, case study one. This is the database that we're working with right now. And so if I were to store it, I bet you there's going to be a new table right here. Now I'm going to give it something useful, give it a good name. So I'm going to call it coronary summary. And I also have a statistics field. Have you run statistics before while running joins and everything like that already? Of course you have. So just for the heck of it, if I wanted to, hey, while I'm here, I don't necessarily have to. Hey, I'm going to average up the year at which these people died. Because I bet you that's going to be spatial in nature, right? Isn't the age at which people died of cancer by county spatial in nature? You see patterns with it when we did this last week? Yeah. You can see in the western part of the state, people were older and younger and all that other good stuff there. So I'm going to run these summary statistics. All right. Now, what's the worst thing that can happen? You don't get the answer you want. That's okay, no big deal. So I got this summary right here. Let's see what it says. Right mouse click, open. What do I have here? One 14580 had one. Is that a, what's that mean? And I can sort on frequency. Let me sort on frequency, sort descending on frequency. So if I sort on frequency, 28655 had 295. Can someone tell me what that means? The number of deaths from this table in area code 28655. And then area code 28645 had 253. 27360 had 243. And while we were there, we averaged up the average age at which they died of coronary heart disease. Just coronary. So I went and picked out from the ICD codes just coronary heart disease. So I did a lot of kind of work already, but before we did this. And so we had 1,600 different zip codes appear. Oh, that's cool. No big deal. Now, what I want to do is, look what I have here. I want to map these. How can I map these? This is, remember, this is a standalone table. How do I map this thing here? What can I do? Sandra's got her back to me. She doesn't want to make eye contact. What are you going to do? How are you going to make this a map? We went through the trouble of running this summary and picking these things out. I've got a zip code. How can I make a map on this? This is what I want to do. This is why we're here. Turn tabular data into spatial data. What are you going to do? You got any ideas, Alondra? Not spatial join, but what? What's the other join we got? Tabular join, exactly. She's on the right track. Not quite a spatial join because spatial joins are going to have spatial relationships. This is tabular relationships. So basically what I want to do is just add this table to the end of my zip codes, right? When I open up my zip codes, I can map stuff. Watch this. I got my zip codes right here. I can map what? You know, if I wanted to, I can go and map Graduated colors. You can map, I can map population right there, right? I want to map number of deaths. That's what I want to do. So how do I do that? And like we said before, we'll run a spatial join. So I'm going to right mouse click on zip codes. Go down to joins. We already did this in week 1. But instead of adding a spatial join, we're going to just add a join. And I typically use the term tabular join to differentiate it from spatial join. So I'm going to add a join. All right, now we got directions here. The one thing about these tools is that they're incredibly powerful. The bad thing is there's lots of drop downs here that you got to kind of figure out what we're doing here. Now our whole goal is to add that standalone table from the summary to the end of the tabular table, the attribute table, and run it. So zip codes and study area. So what's the name of the attribute that represents the zip code in this feature class right here? What's the name of the attribute called? What's an attribute? That reads down. What are the names of the attributes in this table? Zip, PO name, state, or pop 2010. What do you think is going to be the name of the zip code that's sitting in the other attribute that we went through and summarized? Zip. My input field is zip. We're going to join it with what? The thing we just went through the trouble of calculating was the summary of the coronary death. And bippity boppity boo, luckily, the other field is called zip. So when I run my join right here, this is what we're looking at. Okay, and this is those of you joining us online, and I'm going to post this tomorrow. So I'm going to give it a minute here. So I'm going to run a join, and all I'm going to do is I'm going to add the summary table to the end of my attribute table. So now I'm going to have a frequency and an average age of death right here. So now instead of me mapping pop 2010, I'm going to map frequency or whatever. Now there's still going to be some challenges with frequency as well. Here we go. You notice here we've got 82 zip codes. How many zip codes did the other attribute table have? The other table have? Like 1,600, because it was for the entire state. But we're not going to worry about those other ones then. Okay, keep all target features. If you wanted to, you can click this little validate join. This kind of just says, hey, look what I have here. I'm gonna click clear right here. Make sure it's cleared. So when I run it right here, it's going to say, hey, I've got a join for 80 records, but there's 82 down here. Oh. So I only found 80, but there's really 82. What's wrong? What do you think's happening with those other 2 right there? Zips, no, it doesn't have any. There's no zip there. Remember? So there's going to be a couple of zip codes in here that don't have anything. Let's not worry about those for now. Close. All right, I'm going to wait for some magic to happen. What really happened? Oh, what happened? All I did was just add that table to the end. And so now I've got 82 right there. There's going to be a couple of zeros. 13, 13, 8, 10, 34, 31, 159, 91, 17. Who wants to make a map out of this? I do. Now I can go down. I'm going to map frequency. Why don't we have anything right there in the middle? Why is this missing? This is one of the nulls right there. What is right here in the middle of Oak County and Cumberland County?
It's Fort Liberty.
Yeah, Fort Liberty. Does anyone live there or live in these particular zip codes? No. Yeah, they might live they might live like in these zip codes, but I would imagine Fort Liberty has its own designated firing zone zip code or whatever, and I'm sure it has a couple of zip codes, but you're right. Here. Now, basically, what am I looking at here? Why do you think, just looking at this, why do you think we've got 159 deaths right here? Well, it's got 37,996 people versus this one, which has literally a tenth the people, almost a tenth, 20th the people, a tenth the people. So, is this really a map that you're proud of? We're getting there. Now, we've got some neat things that we can do up here. Under normalization, if I just wanted to give a quick look to it, under normalization, I can just click on Pop 2010. What did I just do? Under normalization, what did I just do? I normalized it by population. Now, what do these numbers here represent? 0.00006448. That's per what? Per capita. What does per capita mean? Per person. Per person. Okay. We can go and add our own field to calculate, hey, I want to do this in per 10,000 people. I don't want to look at this stuff right here. I don't like this. But now, what happened to the death rates? Where did they move in this study area here? They moved a little further south, right? And I can do natural breaks. I can click quantile. What about quantile? What do you see about the area up in Harnett County and Hope County and Lee County? What do you know about the heart disease death rates up there versus down in Bladen County? Do you know, is there anything spatial about this map here? So with coronary heart disease deaths between 2011 and 2013, there's some distinct spatial differentiation. Now, I find this really neat because you think it's like, wow, this is pretty specific, right? This is pretty specific data we're looking at. And even mapping it here, you know, we do have a couple outliers. We see a yellow next to a red, so it could be a high year, it could be a low year, but generally it's much higher in Bladen County, much lower in the northern part here. And we're not age grading or doing anything like that. Now we're working with these columns. Now, when I went to Fields View, why do you think there were so many boxes unchecked there? Why were there so many boxes unchecked? I'll circle back to this again, but I go to Fields View. Why is there so much stuff unchecked here? Do you want to see a column for white or age 0 to 5? Do you want to see all this other stuff here? No, it's useless. What are we looking at? What's the goal of it? Normalization. So we don't care about any of that other stuff. We'll talk about age grading in a little bit. Okay. Now, last thing we'll look at today, we'll do here is that I want to create a brand new column because if I were to go and map this stuff here, what do you think most people are going to say? What the heck do these numbers mean? I know what they mean. All it is we're mapping 13 divided by 3772. That's a really, really small number. I want to put these in units. And so when you work with demography, sociology, crime analysis, people are going to want to say crimes per 10,000 people, or crimes per 100,000 people, or rates, or whatever. And that's the whole goal of today when we talk about the idea of normalization. So now I want to add a brand new field. So now I've got zip, PO name, date, top 2010, object ID, and this is object ID is generated by the computer. Zip, frequency, median age. I want to add a new column here, and it's just going to be the product of a couple of these other columns. So once again, I got my little context menu. I got something called Fields View. What can I do? Let me go down to the bottom, and I want to add a brand new column. So you notice I've got the join table. I'm going to go all the way to the bottom. Previously, it had like add column, but I can't do that here. So I'm going to just go down here. And is there a place that I can click to add a new field? You bet. So I'm going to click to add a new field. And what am I going to do? I want to make a field called what? What am I mapping here if I'm doing What am I mapping? Tell me in words what I'm mapping. Normalize. What am I mapping? When I normalize, what am I mapping? What phenomena am I mapping? Rates, right? Rates. So I'm going to call it death rate. Okay. So that's the name of the field. It's called death rate. Me, if anyone who knows me, I don't like putting spaces and stuff. I'm a big underscore person. I don't like putting faces. And it's going to be an alias. What's an alias? What's an alias in real life? Another name. So I'll just, if I want to see how it looks like in the table, I'll do this. Now, the $1 million question is data type. We got short, we got long, we got float, double, date, text, blob, grid, raster. What data type are we going to work? We want this. What type of numbers are we going to have? Big numbers, small numbers. Do we want? Are there going to be decimals here? Yeah, decimals. So we don't want it to be a long. We don't want it to be a short. Because if we're working with like Pop 2010, it's a long or short. Typically, I store things as long. Here, it's going to be a float or a double. A double and a float are the same thing. There's just more space. So I could store like 87 trillion.52739, where that float might not have the ones and zeros kind of running in the computer to store a big nasty number like that. So I'm going to store it as a double. Double means double precision. Store it as a double. And I can go over to numeric. And if I really wanted to, I could say, hey, I'm going to store it as a number and store it with 6 decimal places or 3 decimal places or line it up to the left or whatever. And this is new with this version of ArcGIS Pro. Pad it with zeros, show plus signs, show thousand separators. Meaning it'll throw little commas in there, but it won't be text. It won't count those commas as text. Because once you start seeing commas with dollar signs, you're like, oh, yuck. It gets nasty. Is it treating it as text or is it treating it as something else? But I can change it however I want. Okay. When I'm done there, up in the top, I can click Save. Excellent. What do you see here? What did I just do? You see anything new with my table? What'd you do, Zanaya? Did you add anything new? Yeah. I got a brand new column here called death rate. Okay. Now I can right mouse click on this column. We've looked at these before: sort ascending, sort descending, statistics, summarize. We've done some of this already. What we're going to do is we're going to calculate a new field. Have you calculated a field in Excel before? We did last week. Now, in this case, field is going to be an entire set of attributes, meaning it's going to calculate it and it's going to do the drop and drag. So we don't have to worry about anything. So I'm going to calculate field. In some things, if we run like a select by location, I might only pick 30 of them and calculate those 30 with one calculation, another 20 with another calculation, the remaining things with others. This calculation is going to be uniform. Now, when we calculate rate, what's our rate going to be? Do we want to do it per 1,000, per 10,000? What do you think is a good number? It's not going to be per capita because I don't want to look at this stuff here. We could do per 73.9 people, but we typically want to make nice round numbers. Now, how can we do it per 10,000 people? For every group of 10,000 people, because we know what 10,000 people looks like, how do we do this? Now, how do we do per capita? If I calculate rate, it's just going to be the frequency divided by the population, and then per 10,000, what do? We just multiply the whole thing by 10,000. So when we think about the actual formula, and I'm going to point you folks joining us here, and then I'll point it back here in a second. I'm just going to write it down, is that because I'm going to write it a couple different ways. So it's going to be what? The number of deaths divided by what? Total pop. Then we multiply the whole thing times 10,000. Okay? That's what we're doing. And we're doing this zip code by zip code basis. All right, so these are all going to be local statistics. Now, let's think about it. What's the column? So now I know what 10,000 looks like. What's the column we're looking at here for the total number of deaths? Exactly. Frequency. What's the column for population? Population. These days, you don't even have to type this stuff in. When I did this long time ago, we had to like type it in and if it was wrong and all this other stuff. And so what we've got here is, we've got code blocks here, but zip codes and study area, what we got here? We got a little multiply, divide, plus, minus, equals, all that good stuff ready to go. So what are we gonna do? We're just gonna go left to right. And then what am I gonna do? I'm gonna do 10,000. What's the significance of 10,000? What's so important about 10,000? When I do 10,000, basically, what am I doing to these tiny little numbers right here? That's all I'm doing. I'm moving the decimal point over 4 places. So instead of me looking at 0.00469, I'm looking at 49.69. That's all I'm doing. I don't want to think about what 0.004969 deaths looks like. I'd rather look at 49.6. I wouldn't rather look at deaths at all. 49.69 deaths. All I'm doing is moving the decimal place over. Otherwise, I would just keep it like this. So 10,000 times what? I already said it. Frequency. Let's find the thing that says frequency divided by Pop 2010. Now, when we look at this thing, these are the fields that we click on. Did I go through the trouble of typing in the little, look at these little exclamation points here. Where did these things come from? Did you type those in? Did I type those in? Or did I where'd they come from? The computer puts those in so that it knows, hey, when I run this code, anything with an exclamation point is gonna have anything between the exclamation points we know is a field. It knows that is a field. Okay? A lot of times if you save like a file, have you ever saved a file name mean like Tim's stuff with an exclamation point in it? Why not? They won't allow you because it's reserved. It says, hey, I know exclamation point, pound sign. Those things are special. They're special. So 10,000 times coronary summary frequency, and that just means the originating table divided by zip codes and study area. So this thing before the dot just means the table that it belongs to. Because remember, we ran that join. So it's just saying, hey, you belong to one table, you belong to the other table. To me, it all looks the same. What do you think is going to happen when I click OK? Uh-oh. What happened? Did it yell at you for something? Why did it yell at you? What happened? Certain rows are null. Certain rows are null. Why? Why did it give us certain rows are null? Because we had a frequency of 0, and these were nulls. These frequencies were nulls, and so it was doing like 10,000 times null divided by Pop 2010. And so that's it's yelling at you because it's saying, hey, it's nulls. I'll go through and calculate it. So if I really wanted to, where I see these nulls, I can highlight those. Right mouse click, calculate field. I went through the trouble of doing this just for these two. Guess what I'm going to do? The rate's going to be 0. So you saw what I did. I just highlighted. I could have done a select by location and look for everything where it's null. You got Pope, in Fort Bragg Military or Fort Liberty now. This is obviously old. And so now we've got these rates. So coronary heart disease death rates. Okay, I can run statistics on this. Didn't we do this already? Normalized data we're looking at here. We've got a median, we got a standard median, a mean, a standard deviation. Can you calculate z-scores for all this stuff? You bet. Do I want us to? Not necessarily, what's the whole goal of the z-score, Me, I like looking at this stuff here. And now I can go through and now I can right mouse click and click on symbolize. So instead of me using this frequency, normalized, all that other stuff, look what I got here. I've got a death rate right here with real life units that I can go through and map here. We understand. 0 to 30.368, 30 to 40, 40 to 49, 49 to 59, 59 to 81. Death rates ready to go that can be queried and summarized or queried and displayed. Now I can look at. Last question I'll kind of finish up today is when I ran this summary right here, I had 1,600. Now I only have 82. What happened to all the others? Where'd all the others go? 1,600. Because I had this for the entire state. So where'd the other 1,540 zip codes go? Nowhere. Exactly. They went nowhere. Why? Because I'm only working with 82 zip codes. So when I ran that join, it only joined with the frequency. All those others that didn't find a join, it said, sorry, I can't find a join here. You're not getting a frequency. You're not getting a mean year. You're not getting any of this stuff attached to GIS data because there's only 82 zip codes here. And so you can do this for certain study areas. You can bring in another set of North Carolina zip codes, the entire state's zip codes, create that summary. We already created the summary table and do the same exact thing for another part of the state. So now we got normalized data. So at the beginning of the day, what were we sitting with? We were sitting with this vital statistics database that I put together. I created out the heart disease or coronary death rates. And now you've got a normalized map sitting here ready to go. That's amazing. Now, some of the other things we'll talk about later is that, there might be old people that live here. And that's, when we look at ages, people that die, those are the people that tend to die at those ages. Okay. And so what we're going to talk about, the homework, I'll mention it real quick, but like I said before, the homework will be due in 2 weeks. It's going to be 2 parts. And so in essence, we can work on it all next week, or you can kind of start it now. But when I open up the homework, I thought I had the homework open. But it's actually not due until next week. I didn't even post it. But when we open it up, you're going to look at the same thing. We're going to be looking at deaths, and joins, and all that other stuff right there. So we're going to work on exercise 3A this week. But we talked about the idea of normalizing data. And then we've got a death rate. So what you're going to be doing is the same exact thing that we did here. You're going to be calculating it for data that we worked with our spatial joint. Can you count the number of cancer deaths by county? So you did that for exercise 1, and you brought it into exercise 2. So if you have trouble, refer to the stuff in exercise 2. So if you have the number of deaths and the population, can you calculate a rate? I hope so. And I asked you to do something called a scatter plot. And so we'll look at a real quick scatter plot here today, and then we'll be done. Has anyone heard the term scatter plot before? Scatter plot, we map two things. Typically, we see lines like y equals mx plus b, but I can map two things against each other, where I can map, hey, let me map the death rate against the age at which people die or something like that, or the median age. So I can right mouse click create chart, and I create a scatter plot right here. So I can look at, all right, my x-axis is the mean age versus the death rate. And so for all the zip codes, I've created a scatter plot. Okay, this is just a scatter plot on these here. And you see here, it's got a positive slope. Remember back in the day, math class? And what are we looking at here? We're looking at the idea when the mean age goes up, the death rate goes up. Is that kind of counterintuitive? As the age of people who die goes up, the death rate goes up, right? Older people die. And so you're going to be looking at the same thing for cancer death rates at the entire state level with these scatter plots. So I refer to, I'll post a reference to it, but we've got this scatter plot where we look at kind of two variables. If you want real quick here, I'll show you a really funny one right here, and then we will be done. I swear this time we will be done. So we'll do the first part this week. If you want to work on it, if it's fresh, if you just want to do it all next week. And I'm giving everyone kind of an opportunity to play catch up on exercise 1 and 2. So if you haven't turned it in, turn it in. I won't assess any late penalties kind of starting after week 3 when we play catch up. I'll probably start assessing penalties on this here. But what we're looking at in exercise 3 is this joined counties that we already did. We've got the cancer deaths here, and so I want us to calculate this. But if I were to look at counties where I create a chart, a scatter plot, and this is at the county level. So if I were to say, hey, let me see if there's a relationship between the median age and the average family size. Median age and the average family size. What do you see here? This is kind of interesting, like 0.5 here. We've got these points. What do you see here? As the age of each county increases, the family size decreases. Does that make sense? Yes, you can't be like me and have kids at 47. So most of them are getting them out of the house. Okay, so but what we see here, and we have something here called r squared equals 5. So we have this scatter plot here. In theory, there should be things showing up here. I'm not sure why they're not. But we can see a distinct relationship between median age and average family size. As median age increases for counties, the family size decreases. That makes sense, right? Because people are getting, people are all making, families. In theory, when we normalize an age grade, this line should be horizontal, right? In theory. Because if I were to map death rates or something related to family size and median age, you're going to say, no, duh, that makes sense because old people die or high families, families are going to have some sort of relationship related to income. And so when you run exercise 3, you're going to make this scatter plot and you're going to say, yeah, of course, if I were to map cancer death rates, of course, it's going to be related to age because old people die at higher rates. And so this is where we get into age grading, which we'll talk a little bit more about, but we've got some really neat papers that we've done on this, and there's lots of different ways to do it, where basically you created a weighted average, each age cohort. Now how to do weighted averages. It gets really ugly really quickly. So we're going to kind of step off of that with stuff now. So we got exercise 3A, exercise 3B. They're kind of two separate projects that'll be done this week and next week. And then in the meantime, play some catch up, Esri tutorials, and I have a reading due next week, right? So a reading due next week for all grad students and then undergrad students if you want to start getting yourself some extra credit. So there's lots of stuff to do. Done. I'm done. Yes.
The factors are showing up on mine. We're not,
Did you unzip it? Yep, unzip it. So I'm gonna stop sharing, stop recording.